All right, we are going to start our first online geometry lesson, 8.1 Pythagorean Theorem and PPTs. So we're starting fresh with the new section for Thursday, 4:15. Our goals today, we are going to simplify expressions using square roots. We are going to use the Pythagorean Theorem to find missing side lengths, and if you've taken physics, you've probably used that before. And we are going to determine if they form a Pythagorean triple. First thing we need to know are the first 20 perfect squares. I did have a nice bookmark made up for you guys, but since we're not in school, you won't be able to get it. These are the ones you should know that you probably will need to use the most. And you'll probably need this again in Algebra 2 as well. But 1 squared is 1, 2 squared is 4, 3 squared is 9, and it goes on and on. So the numbers on the left side of the equal sign are what gets squared. The ones on the right side are the perfect squares. How we are going to use these to simplify a square root. We're going to factor the greatest perfect square out, and then take the square root of that, pull it outside of the square root. We treat square roots like a parenthesis. So there's a couple ways to do this. One is you can make a factor tree. And for 112, you have 112 and 1, 56 and 2, 28 and 4, and 16 and 7. If we look back at our perfect square list, the largest one that's a perfect square is 16. So we can rewrite the square root of 112 as the square root of 16 times 7. All right, the square root of 16 is 4, so we can pull that out of the parenthesis, out of the square root symbol. 4 times the square root of 7. Another way you can do that is take your number and start dividing it by the perfect squares to see if any give you a whole number coming out. So if you do that with 180, take 180 and you divide it. You don't have to start anywhere above 180. So 180 divided by 169, not a whole number. Divided by 144 doesn't work. And divided by 121, it gives you a decimal. So if it gives you a decimal, it won't work. And if you work your way all the way back, you will get it's divisible by 36. So it's 36 and 5. All right, so this can be written as the square root of 36 times 5, since 180 is divisible by both of those. Take the square root of 36, that's 6, so the answer is 6 times the square root of 5. That is simplified. And the next one, 294, if you do that the same way, you start dividing by the perfect squares, you'll end up getting that it is 49 and 6. 49 is the largest perfect square factor. Square root of 49 is 7. Pull that out. 7 times the square root of 6. All right, and the last one, if you want to do that on your own, you can. I don't feel like doing it. It's kind of big. We don't need to do that. We'll skip it. All right, now using them, we're going to use this when we reduce in the Pythagorean theorem. So we are going to start. Pythagorean theorem is a squared plus b squared equals c squared. A and b are the legs. The one that really matters is the hypotenuse is always opposite the right angle. So c is the hypotenuse, it's opposite of the right angle. Look for that one first. The other two don't really matter. You could call one A and the other B, either way. All right, so for the example, the hypotenuse is 15, so C is 15. We can call this A, and the unknown is B. So a squared plus b squared equals c squared. 12 squared plus b squared equals 15 squared. 144 plus b squared equals 225. Subtract 144, you get b squared equals 81. Square root of both sides, b is equal to 9. So we know that this side has to be 9. All right, on the next one, same idea. This is C. It's opposite the 90-degree angle. So 8 squared plus 10 squared equals C squared. 64 plus 100 equals C squared. All right, take the square root of both sides to simplify, and we get C is equal to square root of 164. Look for perfect square factors. This one happens to be 4 times 41. Square root of 4 is 2, so it reduces to 2 times the square root of 41. You could also write this as a decimal if you just plug it into your calculator, take the square root of 164. You could do that as well, but if we're leaving it in perfect square factors, it's 2 times the square root of 41. It will be important when we get into some stuff later that you do keep perfect square factors. All right, and our last piece for today, the Pythagorean triple. It's a set of 3 non-zero whole numbers, a, b, and c, where a squared plus b squared equals c squared. So the numbers have to be whole numbers. Our first example, 3, 4, and 5. 3 squared is 9, 4 squared is 16, and 5 squared is 25. 9 plus 16 is 25. That works. They are a Pythagorean triple. What that means is if we have a right triangle, remember these all have to be right triangles. One side is 3, one side is 4. Well, the other side has to be 5. All right. The second example, 1 squared plus 2.4 squared equals 2.6 squared. So 1 squared is 1 plus 5.76 equals 6.76. That is true, but it's not a Pythagorean triple because they are not whole numbers. So they make a right triangle, but they are not whole numbers. Not a PPT. Or not a Pythagorean triple. All right, next. 16 and 30. Look for the hypotenuse. That is C. So 16 squared plus 30 squared equals C squared, and I know it's not to scale. 16 squared gives me 256. 30 squared is 900. And I'm going to bring that up here. That gives me 1056 is C squared. Take the square root of both sides. And if you type that in your calculator, you'll get 34 is C. So that this side is 34. That is a triple, Pythagorean triple, because they're all whole numbers, 16, 30, and 34. And part B, 7 and 9. This is the hypotenuse, so the hypotenuse is 9, and we can call this B. So 7 squared plus B squared equals 9 squared. 49 plus B squared equals 81. And we'll get b is equal to the square root of 32. After you do some subtracting, take the square root of both sides. There is no perfect square of that, but it does have a perfect square factor. That can be written as the square root of 16 times 2. Square root of 16 is 4. So this side, b side, is 4 times the square root of 2. All right, it is not a Pythagorean triple because that is not a whole number. All right. At the very bottom, this is a list of the most common PPTs that you would see. We will go over that in the next lesson in a little more detail. You do have a worksheet that you can do for your homework assignment for this that will be due a week from today.